Alright, what's up everybody, Mr. Mira here, and today we have another Java video. I'm going to be talking about Big O notation. So once we get to the point in development where we have all the requirements met, code is working, it's been thoroughly unit tested, then we can start thinking about optimization. Optimizing by looking to see if we can improve the runtime of our code. When I say runtime, I don't mean how long the code takes to finish in seconds and minutes and hours. That's not what I mean by runtime. In computer science, the runtime is determined when we count the number of steps it takes to complete the algorithm. This is known as time complexity. So let's open up our project file here today, and I think we're doing Goodwill Hunting. Yes, we are. So we have our code, our class, our public static void main string array of args. Now, Big O notation is a special way of describing runtime of programs. It's read in the terms of, so you might see something like O-N, or let's write that as a comment, O-N, or something like O1. Now, how we read these is we say O of N, or O of 1. We use the word of, O of, and then whatever's in the parentheses, not the word to. So you don't say like O to the N, O to the 1, O of N, O of 1. We also, when we're determining the time complexity, it's always given in the worst case scenario. So let's actually write a small program. I'm going to get a small program on the screen here, and then we will talk about its time complexity. It's going to be very simple. So give me a few minutes here, type it all out. It'll be sped up for you. When we come back, we'll have some code on the screen that we can then talk about. Here we have an array of numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8 numbers in here. Then we have a for loop. Inside our for loop, we add 1 to whatever the current value we're looking at is, and then we subtract 5 from whatever that value is. So we have 2 steps inside our for loop. When thinking about Big O notation on this little program that we wrote here, what would its O notation be? So we have an array of size 8. We'll call that N for right now, because it could be 7, it could be 100, it could be 1,000,000, but it's 8. We want to change the value inside of our for loop. We change the value. In order to change the value, we're adding 1 and then we're subtracting 5. Those 2 steps we do for every single value in our array. So we have an array of size N, and then inside our loop, we loop over the entire array, but then we have 2 steps in there. So for every value of N, we do 2 things to it. But those 2 steps, these 2 steps never change. It doesn't matter if I only have 3 items in my array. It doesn't matter if I have 10,000. It doesn't matter if I have 50,000, 50 million items in my array. I'm always going to do 2 steps. So those 2 steps never change. Therefore, the only thing that is impacting how many times these 2 steps execute, how many times I have to go through the for loop, is how many items are in my array. So the Big O notation of this program here is O of N. Linear time happening with this for loop. The only thing that matters is how many items. How many items? Do I need to do it once? Do I need to do it a billion times? It's still 2 steps no matter what. For each item is 2 steps. So that 2 kind of goes away. It doesn't play a role in the overall determination of the Big O notation. I want to end the video here by looking at what we have known as a Big O cheat sheet. Now this is a great website, so give me a second to pull this up. So this website shows off, very colorful, the various runtimes we have. Remember log time, so we see here log n and log n. Log time in computer science is a base of 2, not 10, so it's base 2. And we're going to look at kind of this chart in more detail, what it all means and everything like that. But this is a really great website, bigocheatsheet.com. If you just search up Google Big O cheat sheet, it's going to be the first one that comes up, and it gives awesome time complexities for various different things, which we will be talking about, how we access, search, insert, delete, etc., etc. There are different algorithms for sorts and tells us our worst case, average case, best case. Awesome website. Cannot brag about it enough. Very useful, very cool to study up on Big O notation. In the next video, we are going to look more specifically at the runtimes we get in our code and what that means and how we can identify quickly skimming over code what its runtime is probably going to be. That's going to be in the next video. Until then, everybody, have a week.